Amazing.
Vedantu. Learn live online. To attend a free live class, download the app now.
Hello students, very warm welcome to you all. Good evening. And in today's session we are going to do few questions of magnetism. So let's get on with it. Before we start, I would like to tell you that we are right now selling all our micro courses for ₹9 only. So I guess that's a very good opportunity. Do not miss that. You can avail this offer currently and pretty soon it will be withdrawn. So make sure that you are making full use of it. Alright guys, so let's get on with our questions. I'm Vikas Sir, taking you through this session. So this question talks about a circular conducting loop of radius r carrying current, which is not, the direction of the current has not been shown in this question. We have to figure it out actually. Is bent into two equal halves, one lying in the xy plane and the other in the xz plane. So there is a circular loop and we have bent the circular loop from the middle so that it is now half of the loop is present in the xz plane and the other half is present in xy plane. All right, so this is the figure actually. I think I'm coming in front of the figure, so I'll just get, so you can see that half of the loop is in xy plane, the other half is in xz plane. All right, so this is the situation and center lies at the origin, that is okay. Loop is immersed in a uniform external magnetic field which is given by this. So what I can notice from here is that the magnetic field is in y direction and it's in z direction. Like the magnetic field is uniform, all right, and it has two components, one along the y-axis and the other along the positive z-axis. All right, now if the portion lying in the xy plane, so we are talking about a portion of this loop which lies only in the xy plane, so we are talking about this half of the loop. Okay, this portion experiences a net force in a positive y direction, okay, due to the external field. So some conditions has been given to us. Uniform magnetic field is there, that is given to us, and we have also been given the loop. We have not been given the direction of the current, and we have been told that this portion is experiencing, the portion which lies in the xy plane, it is experiencing a force in the positive y direction. Okay, based on that we have to decide on some options, and the options talk about the magnetic dipole moment of the loop and then magnetic force due to the external field on the portion lying in the xz plane, net torque experienced by the loop. So these are the things that we have to worry about. All right, so let's see how do we do this question. I need some space to do this question, so yeah, I guess this will do. All right, so let me just start doing this question. So first of all, I'm wondering about the direction of current in this loop. So to address that, what I need to focus on is I've been told that the force acting on this part of the loop is towards positive y. So this part is experiencing a force in the upward direction. Now how do we find force on current carrying conductors kept in magnetic field? Well, we use this expression. I into L cross B. We use this expression when we have a uniform magnetic field and we want to calculate the force acting on a straight length L through which I current is flowing. All right, but currently the length is not straight, it is actually a curved length. So when we are dealing with random shaped conductors, okay, what we do, we replace them by straight conductors. Okay, we consider that the ends, when we join the ends by a straight line, whatever force will be experienced by this straight line, the same force will be experienced by this curved line also, assuming that the current is same in both. All right, and if the current is flowing like this in the actual wire, which is the random shaped wire, then the current in this straight segment will be assumed like this. Okay, so to know the current or so to know the force in this curved section, what I'm going to do, I'm going to assume that there was a straight current carrying conductor lying here. Okay, so I'll just draw it here again. There was a straight current carrying conductor lying here. The length of this conductor was 2r. I'm still not aware of the direction of current in this straight conductor because I don't know how current was flowing in this loop. Was it counterclockwise? Was it clockwise? All right, I'm not aware, so I cannot decide the direction of current in this straight segment yet. But given that the magnetic field had two components, right? One component was along the z-axis, which is like outwards, okay, and the other component was along the y-axis. Okay, Now, magnetic field never exerts a force on a conductor parallel to itself. Alright, so this component of magnetic field, the component which is parallel to y-axis, okay, that component of magnetic field cannot be responsible for the force which this conductor is experiencing. So it's only the Z component of magnetic field which can exert this force. So there is a magnetic field in this direction. Actually, magnetic field is in these two directions, right? Positive Y and positive Z, but this component is not responsible for force. So this component is responsible. So magnetic field is in outward direction, force is coming upwards, and this expression can give us the force. So I believe if I consider the current in this direction, okay, if I consider the current in this direction, then I cross B, I is in negative I direction. Alright, so negative I cross K is going to give me plus J. Alright, so I am now sure that the current that this straight conductor should be having, it should go towards negative I, which means that current in this part of the wire, should be anti-clockwise, which actually tells us that the current in this loop will be like this, because they are actually one loop only, which we have bent at right angles from the middle. So we are now aware of the direction of current. Okay, so this was the argument. This is the thought process that should happen in your mind to decide the direction of current. Deciding current in this question, or deciding the direction of current in this question, was an important aspect. Now that that is done, now we can start talking about the other factors. For example, if you now ask me about magnetic moment is written as current into area. So current is I, let's say. Now what about the area? So for this area, the magnitude of this area is pi r square by 2, and the area vector will be considered along positive z axis, so k cap. Alright, and as far as this area is concerned, the area that lies in the xz plane, I am going to write pi r square by 2, and this area vector is pointing along j direction. So this is the magnetic moment vector. So I can take out pi r square by 2 as the common quantity, and then we have j and a k. So this is the magnetic moment of this loop. Alright, now if I go back to have a check on the options given, A option talks about the magnetic dipole moment of the loop, and it says I naught into pi r square by 2. So magnitude wise everything is okay, but the direction mentioned here is minus j and minus k, but the direction that we are getting is plus j and plus k. So A option stands to be an incorrect one. Alright, so A option is the incorrect one. We have decided on the magnetic moment. Let's see what the next option talks about. The B option talks about net magnetic force on the external due to external field on the portion line. Now the B option is not talking about the net magnetic force acting on the loop. Alright, a current carrying loop experiences zero force in a uniform magnetic field. So we are not talking about the magnetic force on the entire loop. B option talks about the magnetic force due to the part lying in the xz plane, only in the xz plane. Now the answer to whether this option is correct or not, the answer to this question lies in the fact that the net force on the loop is zero. So this part must experience a force which is opposite, or which is which is negative of the force exerted, the force experienced by the remaining part. So the question gives us the direction only. The part kept in the xy plane, so this part was experiencing a force in the j direction. So that's pretty obvious that the remaining part of the loop will experience a force in the negative j direction. The direction here is given to be correct. I'll have to check the magnitude. Alright, checking about the magnitude is still left. So what I'm going to do here is, okay, magnetic field is given to me. Okay, so I'm going to use this formula now. How to do that? To know magnetic force acting on this part. Okay, to know magnetic force acting on this part, I'm going to draw a straight conductor, the length of which can be written as 2r. Alright, so length of which can be written as 2r. So 2r is in this direction, and magnetic I can use this expression, F is equals to I into L cross B. Okay, this expression can be used here. So the B given was, let me just go back and have a look at B. The B was mu naught I naught by 4r j plus k. So I'll just write it here. B given to us was mu naught I naught by 4R J plus K. Let me just check whether I have copied it correctly or not. Mu naught I naught by 4R J plus K. Yeah. All right. So magnetic field has two components. One along. Yeah. All good. Okay. So how do I write this force? I L cross B. So I naught is the current flowing in this wire also. So I naught into length will be written as 2R into I cap, and then cross B is what I'm going to do. Right, just a minute. Yep. So what I'm going to do here is cross B. So it's going to be mu naught I naught by 4R and then J plus K. Right. So this cross product is going to give me what? This cross product will give me K cap and minus J cap. I shouldn't have got a K cap. Just a minute, guys. I think I'm doing something wrong or what? Magnetic field is given this portion. I'll have to replace by a straight segment. Just a minute, guys. I think I've been wrong somewhere. The portion in the XY plane experiences the net force in the positive Y direction. Portion in the XY plane. Due to the external field. Okay. Yep, I guess only the K component I should check. It should be I naught into 2R. I cross K is minus J and divided by 4R into mu naught I naught. So this is giving me B option as the correct one. B option will be the correct one here. The force should be along negative J only, and it should have a magnitude of this much, which this is what we are getting from here. If I solve this, this becomes 2, so it becomes mu naught into I naught square by 2. Okay, I guess this pi is misprinted, so we should not say the B option is correct one because this pi is creating problems. So B option will not be the correct one. Okay guys, B option will not be the correct one. I have marked it as the correct option, but no, the B option is not correct. And just a minute, guys, just a second. Yep. So net torque experienced by the loop. Net torque will be given by what? We can get net torque by multiplying. Net torque will be obtained by mu cross B. Okay, net torque will be obtained by mu cross B. So mu vector is written here and B vector is written here. Okay, so we have to take the cross product of mu and B. So that gives us the torque acting on a loop. So the cross product of these two is going to give us a result. Okay, I'm not doing this cross product. I'm not completing this. I'll just check the directions actually. So I'm going to get a term involving K and J. So K cross J is going to give me minus I. So I'll have a component of minus I, and then K cross K will give me a 0. Then J cross J will give me a 0, and J cross K. Okay, this is going to give me J cross K is going to give me a plus I. Okay, so mu cross B. I think there has been some mistake here. Guys, I think there is some problem in this question, like something I've got incorrect, like some error has been there maybe. So let's skip this question for now. I think there has been some mistake in this question. So I'll consider that question at the last. Maybe I'll have a second look at it. Let's do the next question right now. This question says that a wire having a current of 3 ampere. Okay, so this wire is carrying a current of 3 ampere, is lying in the XY plane. along the curve 3x equals to y square. So this is the curve that has been given to us, and we have to find the force acting on the wire due to the uniform magnetic field of. So let's do this question. How are we going to address this question? Again, the concept is similar. We are going to consider this wire as a straight segment. Okay, so the length of this segment can be calculated. How can I calculate the length of this segment? The coordinate of this point is 0, 0. The coordinate of this point is 1, root 3. So the length will be root 3 square plus 1 square and root of that. So it is going to be 2. Right, so 2 meter is the length of the wire. In fact, if I want to write L as a vector, I'm going to write it as root 3I plus j. So this is how I'm going to write the length vector. Now force is given by I into L cross B. Okay, so I is how much? I is 3 ampere. So 3 into L. L is root 3 I cap plus j, and cross B. B is how much? B is acting at an angle of 30 degrees. So I'm going to write B as 1 Tesla into cos 30 I cap plus sine 30 j cap. So this is what I'm going to write, and when I take the cross product of this, okay, 3 remains as it is. Root 3I into I, that's 0. Root 3I into j, so that will become root 3 by 2 into k, and then j cross I is minus k, so it will be just a minute. Okay, I guess it will be 0 only, because this length becomes parallel to this magnetic field. The coordinates are 1, root 3. No, so this will be what? The y component is root 3 actually, not this one. It is I plus root 3j. I'm seriously doing some mistakes here, doing some serious mistakes here. So actually this will be 1 and this will be root 3. So my cross products will be different. I'm going to get half into k cap, and then I'm going to get when I multiply these two, minus 3 by 2 k cap. So I'm going to end up with 3 into minus k cap. So the force will be 3 Newton. The force should be 3 Newton. I guess 3 is the answer given here, but I can also give you an alternative way of doing this question. That alternative way would be, you can figure out that this angle is 60 degree and this angle is given to be 30 degree, which means the angle between the length and the magnetic field is 30 degree. So even a direct calculation such as ILB sine of angle between them will give you the result. Okay, this will be actually a quicker method, because in this we don't have to go for the cross product. Alright guys, so the correct answer here would be 3, and 3 is given to be the correct answer. Alright, yes guys, today I am committed mistakes in both the questions, or maybe the first question I doubt something is wrong in the first question. I'll have a look at it again, not in this session, but after the end of the session I'm going to have a look at it and I'm going to see whether there was some mistake or not, or maybe if time permits I'll go back and have a look at that question again. So guys, request your patience here. I think I'll be good in a short while. Meanwhile, I'm going to have a look at my friends here. Okay, Mitul is quite surprised. Sanjeev, hi, and okay, yeah, thank you, Shivanshu, that is. Okay guys, so let's continue. Hopefully I'll be okay with the upcoming questions. So particle having a mass m charge q moves in vacuum such that the magnitude of its angular momentum with respect to a fixed point is, okay guys, so this question, I'll first explain the question to you. Now the question says that there is a fixed point and a particle of charge q is moving. Let's say it has a charge q, it has a mass m, this separation is given to be 2 meters, so it's moving like this. How do we write angular momentum about p? To write angular momentum about p, I'm going to use this m, like the vector will be written as m into r cross v. Okay, the vector will be written like this, but if I'm only interested in the magnitude of the vector, I'm going to write it as m into mod of r cross v. So this L is given to be 96. Okay, so 96 is equals to mass. Mass is given to be how much? Is the value of mass given? No, only the expression is given, so I'm going to write it as m into mod of r cross v. Okay, so this is my one equation. Okay, now we have to find out the magnetic field because of this particle at this point. So how do we write the magnetic field due to a moving charge particle? We write it as mu naught by 4 pi into q into v cross r divided by mod of r cube. All right, now this is the expression. This is actually Biocide law for a moving charge particle. So what we have to do, we have to write mu naught by 4 pi and q divided by mod of r cube. R is 2, so cube of that will become 8. So we are going to get an 8 here, and v cross r. So magnitude of v cross r will be, from here we can pick the magnitude of v cross r. It will be 96 divided by m. So I'm going to write 96 divided by m here, and this gives us the magnitude of b. This thing gives us the magnitude of b. So if I compare this expression with the one given here, okay, it's written mu naught by 4 pi q by m. I can see a mu naught here. So mu naught by 4 pi q by m. So 96 by 8. 96 by 8 should become the value of k. 96 by 8 is how much? It's 12. So 12 is the correct answer here. Alright, 12 is the correct answer here. So in this question, we were supposed to use the expression for angular momentum to know the product of r cross v, and then the product of the value of this product is to be substituted in the Biocide law expression. All right, okay, so let's move to the next one now. Now this question says two infinite large parallel conducting sheets. Okay, so this question involves sheets, so we should be aware of how to write the magnetic field due to a sheet. So I'll just tell the formula for once and then I will start the question. So let's say this is a sheet which extends up to infinity in these two directions also, and which extends up to infinity in these two directions also. So this is an infinite sheet, all right, and it carries a current like this, like it carries a current in the upward direction like this. Throughout the area of this sheet, current is flowing like this. Okay, and the current per unit length, okay, current per unit length, that is, if I consider 1 meter length along the sheet, okay, then the current flowing through this region, if that current is I, then it is given to us like this current is generally given to us. Let's assume it's given to us as 1 by root pi ampere per meter. So okay, so in case of infinite objects, we are generally given the densities or the per unit length values or the per unit area values or the per unit volume values. Right now we are using the per unit length. So in 1 meter of this sheet, this much amount of current is flowing from minus infinity to plus infinity like this. Now such a field, such a sheet produces a uniform field in front of it and towards back of it, and that field will have a direction like this. It will, like, if the current is in the vertical direction, then magnetic field will be in the horizontal direction. All right, so if we look at this figure from top, the sheet will appear as a line to us from which current is coming towards our eyes. Okay, so in this figure, current is coming right into my eyes, so I'm going to draw dots here. Okay, these dots are not representing magnetic field, they are representing the currents, these currents. Okay, so they are representing these currents, and these magnetic field lines will appear like this in this figure. Okay, and this magnetic field is actually a uniform one. The value of this magnetic field is mu naught into whatever this linear density of current is divided by 2. It's a uniform magnetic field, mu naught I by 2. Now if I imagine another sheet here, okay, the question talks about another sheet which is kept here, either another identical sheet. So this sheet will be carrying current like this. Okay, this sheet will be carrying current like this. Now understand this, these are current carrying wires and there is a magnetic field here. So every wire, each wire is going to experience a force like this. Okay, parallel currents attracts one another. So this sheet is carrying a current which is outwards from the screen. This sheet is also carrying current which is outwards from the screen. So these two sheets will attract each other. So at every segment of this sheet, an attractive force will be there. So if I consider a length L of this sheet, okay, this much part, so this much part is going to experience forces like this. All right, and let's consider a depth B. Okay, let's talk about depth B of this sheet. So any one wire will experience a force of B into current carried by one wire into the length of this wire. Now length of this wire is into the screen. Okay, I'm considering that as B. So this is the force experienced by one wire. How many such wires are kept? Well, we can't count the number, but I can say that the total current in this segment will be given by, like I should replace I1 by the current density into the length. Length is L. So this is the force experienced by this entire segment. I divide this by the area. Area will be L into B. Alright, so L into B gets cancelled and our answer would be B into the current. Okay, B is this much. So my final answer would be mu naught I by 2 into I, which basically becomes mu naught by 2 into I square. So that's it. We have to find the numerical value. Okay, so let me see if I have some space. No. So mu naught is how much? I'm going to do the calculations here. Mu naught is 4 pi into 10 raised to power minus 7. I square will be 1 by pi, and we have a 2 also. So the pi gets cancelled and the answer will be 2 into 10 raised to power minus 7. So C option will be the correct one. Alright guys, so C is the correct one. So this situation, actually this question, to answer this question you should be aware of the expression of magnetic field produced by an infinite current carrying sheet, the manner in which the magnetic field is created, like what is the direction of the field, is the field uniform or not, and how to find the force on another current carrying sheet here. Alright, I understand that this situation is a bit difficult to understand if you are looking at this for the first time, but you need to grasp these ideas. If you are not familiar with these ideas, I would say that you have to be familiar with these ideas, because questions do come based on such situations. Okay guys, so now we have another situation. This is a very nice question, I would say, one of my favorite questions, like a good question. What is happening here? Stream of particles is being sent here. We are sending us in a stream of particles, charged particles, positive particles, moving with some speed, and this is a region of magnetic field. Half of this region possesses magnetic field inwards, whereas the remaining half possesses a field outwards. So ये जो half है, ठीक है, ये जो half है, in this half का magnetic field is inwards, while in the remaining half magnetic field is outwards. So what happens when stream enters this region? All the particles that go into the upper half, okay, they will experience an upward force and they will start going on a circle. Like जैसे ही यहाँ पे enter करेंगे, ठीक है, यहाँ पे enter करते ही they will experience a force in this direction, so they will start moving on a circle. Alright, the center of which will lie somewhere here, and when they come out they are going to travel straight. Okay, and similar thing will happen with the particles which enter the lower half. जो lower half में enter करेंगे वो downward force experience करेंगे, तो उनका center यहाँ पे कहीं पे आएगा, and they will move on a curve like this, and they will eventually go and hit. So the figure will be symmetrical. It may not appear symmetrical in my drawing, but whatever happens in the upper half, similar things will happen in the lower half. Okay, so we have to find out this distance. Alright, or we can find out this distance and we can double it to get the answer. So this is what we are supposed to do. ठीक है, ये तो physics हो गई problem की, mathematics is still remaining. So as the particle comes here, the particle experiences a force in the upward direction. It starts going in a circle. So it will leave this region of magnetic field at some point, and beyond that the particle will travel in a straight line. It is going to hit the screen somewhere here. If we calculate this distance, the double of this distance will be the answer to this question, because the question is asking for the distance between the point on the screen where the charges will strike. So we want to know this distance. Okay, so let's see how to do this. So I need some space. So what are we going to do? So first of all, this radius, I'm going to calculate this radius. I'm going to name it as r prime. So this r prime is given by mv by qb. All right, now I need some numbers here. Let me go back and have a look at the mass is how much. Mass is given to be 2 grams. So 2 into 10 raised to power minus 3. Velocity is given to be 0.3. So 0.3 divided by qb. Q is given to be how much is the charge? Charge is 1 millicoulomb, so 10 raised to power minus 3, and B is 0.2. Okay, so when I do the calculations, I cancel these two and I end up getting like 3. Alright, so 3 meter is the radius. Okay, so r prime comes out to be 3 meter. All right, so this is 3 meter. This r was root 3 meters. Okay, now the particle will start traveling on a circle like this, and when the particle leaves, this angle will be 90 degree. It will then go straight. Okay, so this will be a cyclic quadrilateral, I would say. This angle is 90 degree, this angle is 90 degree, so this will be a cyclic quadrilateral, and this distance is root 3. In the question, this distance is given to be root 3. The radius of this region is given to be root 3. Okay, this comes out to be 3, which means if I join this to the center, this angle becomes 30 degree. Okay, which means this angle also becomes 30 degree. From properties of triangle, this angle also becomes 60 degree. This angle becomes 60 degree. This entire angle is this angle, so this is 60 degree. Okay, now this distance is 2r, as it is given to be r, so r plus r, this is 2r, this is 60 degree. If this length is x, then I would say tan 60 is equals to x by 2r. So x comes out to be 2r into root 3. Alright, my answer would be double of x, so 2x. So it means 4r root 3. The value of r is given to be root 3. So it becomes 4 root 3 into root 3. So 4 into 3 is the answer. If I go back to check, the question says that the distance is 4x. So in place of x, we are getting a 3. So 3 will be the answer to this question. We are getting 4 into 3. So 4 into, comparing it with 4 into x, x is 3. Alright, so x comes out to be 3. Okay, I hope you enjoyed this question. What happened here? So it was a good question. Alright, so let me have a look at the chats. What's going on there? So Cristiano Ronaldo says some tips. Well, the tip from my side would be just you have to study hard, guys. Okay, like the first and the foremost thing is that you have to put in efforts to learn the subject. Everything comes after that. So you have to learn the subject really well. So that is the most basic tip I would say. ठीक है, मतलब people keep looking for shortcuts, you know, some tricks, something that a teacher says the student hears and the student becomes enlightened. But I'm sorry to say, but such a thing don't exist. You have to study, guys. To get selected, you'll have to study. That's the plain and simple fact. The sooner you realize this, the better it is for everybody. Like everybody means for you, your parents, your teachers. All right. So there's one thing, and yep, Shivanshu is right in saying that study hard in the right direction. Okay, so I guess I can see this much chat right now. So let's keep moving to the next one now. Now this question talks about consider two uniformly charged concentric and coaxial rings of radii r and 2r. All right, I'll keep drawing the figure with this while I read the question. Okay, so there are two concentric rings and one has a radius of r and the other has a radius of 2r. So this is the situation. Total charge on the inner ring is q1. So this ring is having a charge of q1 and this ring is having a charge of q2. That also I can see. Both rings are revolving in the same sense. So they are producing current in the same direction. Okay. If they are moving, so moving charged rings, they are going to create some currents. Okay. With some angular velocity, with same angular velocity. Okay. That is also interesting. So the currents produced by them will be written as q1 divided by time period. Time period will be written as 2 pi by omega. So the current produced by the second ring will be q2 divided by 2 pi by omega. So basically the currents are in the same ratio as the charges. Okay, if the net magnetic induction at the center okay, so somewhere here, all right, if the revolving in the same sense with the angular velocity, so the net magnetic induction is 0. Okay, now one thing is pretty clear, that we are getting a 0 here. That means the magnetic field should be in opposite sense. The rings will produce magnetic field along their axis. Since we are getting a 0 here, they must produce magnetic field in the opposite direction. Their currents are in the same, assuming that both are positively charged. If I assume that, then both are positively charged, so they will produce parallel currents. So they will produce B in the same direction. So 0 cannot be obtained. Alright, this is the case when I'm assuming that both are positively charged or when both are negatively charged. So if both are positively charged or if both are negatively charged, then they are going to produce B in the same direction and a 0 magnetic field is ruled out. It cannot be obtained, which obviously means that they have opposite charges. Okay, they have opposite charges, so that one ring rotates, like the rings are rotating in the same sense, they will produce current in the opposite direction. That will give us opposite B, and now the B can get cancelled. Okay, so first of all, I'm going to check whether we have any positive ratios in the option, because had there been a positive ratio, I would have rejected that answer straight away. Like, let's say if 3 of the options would have been positive, I would have simply selected the negative option. Alright, but that is not the case. All the 4 are negative. So the information that I have obtained so far is not helping me to eliminate any one of the options also. So I'm going to go, I'm going to need more information. So what do? First of all, I write expression of B due to a ring. So that is mu naught IR square divided by 2 into x square plus r square divided by this. This is the expression of B produced by a ring on its axis at a distance x from the center. So can I say that the 2 rings should produce the same amount of magnetic field? Well, yes, only then they are going to cancel out each other. So what I'm going to do, I'm going to write here, I need some space, so I'm deleting these things. Okay, so I'm going to write okay, things that are going to get cancelled, I'm not paying attention to them, like mu naught and 2, these are going to get cancelled. Even I will be written as charge divided by time period. Time period will be the same. So instead of I, I'm going to use a Q here. I'm not saying that I'm writing the expression of B anymore, but I'm writing only those things which are going to make a difference in the ratio. So I'm going to write Q1 into R square divided by R square plus R square raised to power 3 by 2, and this should be equal to Q2. I'm only looking for magnitude, right? So I'm not paying attention to the signs. We have already concluded that the signs will be opposite. So I'm only looking for magnitude now. So X will be R only, R square, and then we will have a 2R square plus R square raised to power 3 by 2. So, oh, actually radius of the rings are different. So here 2R square will come. That's it. Q1 by Q2 will be how much? Well, the R will get cancelled out everywhere. From here we are going to get a 2 square, and this is going to become 2 raised to power 3 by 2, and this is going to become 5 raised to power 3 by 2. So we are looking for 4, so this becomes 8 root 2 divided by 5 root 5. Alright, 8 root 2, 5 root 5, C option will be the correct one. Right, C option is the correct one. Getting this, everybody? Okay, Suraj. Hi Suraj, how are you doing? I don't suppose that your name was same here, Suraj JEE Sprint with. I think it should be different. If you have joined my session using this ID, I don't remember you. Maybe in the sessions your name was a bit different. I do have students by name of Suraj. Right. Okay, so great. Hi Manish, how are you doing? Okay, let's move to the next question now. Let's get rid of this. This is the next question, probably the final one also. So let's have a look at this. Now this is a loop here which is carrying a current. Okay, this is a loop carrying a current, equilateral triangle, and B is in vertically upward direction. All right, so right now the current is clockwise as seen from your frame. So magnetic moment is inside. So magnetic moment is inside, magnetic field is upward. So right now if you ask me, is there any torque on this loop? Well, my answer would be yes. So there is some torque acting on the loop, and that torque will it will basically make this loop to turn like this. Okay, and the gravity will oppose it. Now the question says that the loop should attain horizontal position at least once. So I would say that the loop assumes this position. The loop assumes this position, the horizontal position, before coming to rest. So what I'm going to write? I'm going to write work done by magnetic field plus work done by gravity equal to final kinetic energy minus initial kinetic energy. I'm assuming that in this position the loop was barely able to come to rest. Like the loop started rotating and then it came to this position and then it fell again. Okay, because the torque of gravity will oppose the motion of the torque, the motion of the loop. So work done by magnetic field will be written as, you can simply say that work done by magnetic field is negative of work done by gravity. Work done by magnetic field is what? U initial minus U final is equals to minus mg delta h. All right, so U initial is how much? We write U as minus mu dot B. So that is the negative of dot product of magnetic dipole moment and magnetic field. Initially these two vectors are perpendicular to each other, so U initial is 0, and finally they will be in the same direction. So we are going to write minus mu into B is equals to minus mgh. Now what we have to write is mu. Mu is how much? Current into area. How do we write the area of the loop of a triangle equivalent triangle? It's root 3a square by 4 into B is equals to m, g and h. Actually we have to write delta h. So height has increased. Okay, now I'm not paying attention to the signs anymore. Okay, so U initial was 0 and U final was actually negative. Delta h will also be negative, and hence I'm not paying attention to the sign. So I'll just erase this. H will be how much? Well, this center of mass will lie somewhere here. So this is the increase in height, because when the loop assumes the horizontal position, this point reaches the same level as CD. So it will be written as 2 by 3 of length of the medium. This ratio is 2:1. Okay, so 2 by 3 of the length of the median, which is root 3a by 2. Okay, so we need to solve this equation. Solving this equation will give us the desired result. What we want to know? We want to know the minimum value of B. So solving this equation is going to yield the result. I'm leaving the calculation to you guys. It's pretty simple. You have to just punch in the numbers. The value that you are going to get will be 400 millitesla. Okay, the value is asked in millitesla, so the answer would be 400 millitesla. You can finish the calculation. You will get the answer. I have done this, and the correct answer will be obtained. All right, guys. So I'll just show you the answer also. 400 will be the correct answer. All right, guys. So with that, I guess we have come to the end of this session. Would like to tell you about this crash course that we are currently undertaking. You can be a part of this. You can be a part of, just a minute guys, this course by using this link. All right, and make sure that you use this coupon code to avail a good discount. I guess the prices have further decreased. Few days back it was 9,500. I guess it has further decreased. So do not let go of this opportunity. Make sure that you utilize this opportunity. And on that note, I'm going to end today's session. It was fun doing this session with you guys. Keep watching us and subscribe our channel. Hit the like button if you liked what work we are doing here, and share this video with all your friends. Thank you so much. Bye bye. Take care and have a good night.